Hello, everyone. How often we do... Excuse me? Oh, sorry. How often do we see at something, but do are looking at something, but do not see? We pass by some valuables and ignore them. We ignore them. We don't pay attention to valuables and talents or hidden resources, and these resources remain unused. How often it seems that resources has run out, but in fact it has not. The same thing is with minerals. We usually take what we see. We dig in the ground until we see gold, and when we see gold, we take it. Do it in the usual way. Wash metal from bedrock using gravity. You may all remember California gold rush. At that time, thousands and thousands of people arrived in search of gold. Yeah, but we all know they were not miners who eventually took advantage of a rush, but business people who sold equipment. Anyway, that miners did in their hope to find any gold was sink the pen into the water and shake the dirt away to reveal some gold. How does it work? I need two things to explain it. An apple and a crumpled piece of paper. Next, I blow. Let's watch what will happen. This is how gravity works. Gravity works in this way. The denser and heavier particles remain in the water, a gas flow, and light particles are washed away by the flow. Gold is a really heavy metal and falls down to the pen, to the bottom of the pen, and bedrock is lighter and is moved out to the waste. This is what is left after miners take all visible gold. But if you look deeper, you'll see what these heaps of waste hides, from 30 to 50% of invisible gold. Is left. There are dozens of tons of metal in some gold mining sites. Why is so much gold lost? Ores hide gold inside. These ores are called stubborn because they resist and don't give gold away. Such gold has micro and nano sizes and is hidden inside ore crystals. To persuade crystals to give gold away is extremely difficult. We use force to do it, but not any force will be suitable for it. Besides, there are both stubborn ores and double stubborn ores. The problem with stubborn ores is resolved through oxidation. We can oxidize them using bacteria to break up crystals and extract gold particles. Then it comes to double stubborn ores. The situation looks more complicated. They contain carbon, for example, which absorbs gold, and carbon is not oxidized by bacteria. We can burn carbon, but in this way, gold will vanish with carbon and will lose it again. We need to extract invisible gold. To solve this problem, we use cavitation. It is very easy to remember. We use gravitation to extract visible gold and use cavitation to extract invisible gold. Cavitation is a very strong force. It is a process of bubble formation which then collapse in water. I'm going to demonstrate a visual experiment of cavitation destructive force. And this trick with bottle that bartenders don't like. I'll show you. I have a bottle. It's filled with water. Let's watch how cavitation works. What's happened? The bubbles created at the bottom of the bottle when I hit on the top. Instantly, bubbles will collapse with much power at the bottom of the bottle comes off. It's happened because of cavitation. If a bottle is empty, cavitation doesn't work, and bottle will be unbroken. However, if I fill it with water, cavitation will work again. Let's test it. Is it fun, huh? This is a reason why we use bubbles in our research, actually the power of collapsing bubbles. I've told you about collapse, but now I want to show how it happens. It's amazing. Each bubble behaves in this way. It's amazing slow-mo because cavitation speed is 400 to 1500 meters per second. The temperature inside bubbles is up to 27,000 degrees Fahrenheit. Gosh, it is 3 times as much as the temperature of the sun. The pressure peak inside is at 7,000 atmosphere. It is 7 times as much as the pressure at the bottom of the Mariana Trench. The gas erupts into crystals of ores. You know, after 2 knockdowns I myself have experienced, I thought boxers have the strongest punch. No, bubbles are stronger. These punches create crack, split, and destruction in crystals right there. We need it. Why? The structure is stronger when it's normal. But there are 2 cases of stress in structure. The first one occurs when there is something missing in structure. The second one happens when structure has something irrelevant. This case, it is gold in ores, yeah? We use the stress, this stress to crack structures. After crashing the crystals, we have a gold separately and bedrock separate too. And we can't get gold yet because it is very small, you know, micro and nano sizes. Next, chemistry comes on stage to help us. We develop and produce special reagent. It contains different chlor acid bases, and they turn into each other and generate different mixtures. Our reagent is like a carrier. It picks up gold from ores and gives to us. After regeneration, it can be used again. Our reagent with cavitation together generate an aggressive condition complex. As a result, we have the better and cheaper methods recovery of gold, cheaper that standard cyanide methods. Afterwards, there is another problem. We can just add the reagent to the ore and look how it takes gold. No. In this case, gold is turned into a solution after reaction with others, copper, carbon, etc. In this way, it spent a lot of reagent. And rise the cost of our process. It's looking not competitive yet, but we are working to that, and we generate best reagent to recovery gold only. And as a result, in future, those waste heaps will be transformed into gold heaps. Why not? To conclude, I'd like to say that we have to use all our resources, both in mining and in our life. Use them all up to an end. Thank you.